Alright, as we continue to look at lesson 24, we're practicing finding surface area of a triangular prism. So it says to use what you've just learned about finding the surface area of a triangular prism to solve the following problems. Show your work on a separate sheet of paper, but it's fine to work in the book for this problem. It tells you to find the surface area of the prism. If we do that, we have to be able to identify how many surfaces. We need to find the area for, which in this case of the triangular prism is how many surfaces? 5. 2 triangles and 3 rectangles. So if you start doing the breakdown and you find the different areas to combine, we might start with the triangle because we know that the top triangle and the bottom triangle are going to be the exact same. The measurements for the top triangle are 8 and 6. And if we want to find the area of that triangle, then we follow the formula. Area is the base times the height divided by 2. So that's going to be 8 times 6 divided by 2, which is 48 divided by 2, which is 24. Now that's the area for one of the triangles, but because we have 2, you can double that and go ahead and say that 48 is the entire area for both triangles. And now we can continue with the rectangles. As I look at this rectangle, I think to start with one of the sides. And one of the sides would be 8 by 7. So to find its area, you would do length times width, which is 8 times 7, which is 56. As you look at this figure, do you see another rectangle that is also 8 by 7? No. So we add 56 and begin finding the area of another one of the 3 triangles. If you look at the other side, it's easy to think that it would be a duplicate, but if you pay attention to the measures, you see that it's not, because that side is 6 by 7. So to find its area, that is length times width, which is 6 times 7, which is 42. Is there another rectangle that is 6 by 7? No. So we'll add 42 and find the area of the last rectangle. And the last rectangle is 10 by 7. So its area is length times width, which is 10 times 7, which is 70. We've now accounted for all 5 sides, and we should add them together. And when you add 48, 56, 42, and 70, you come up with 216. Now typically we would put inches squared or feet squared, but because we don't know what the unit of measure is, we just call it units squared. In problem number 9, it tells you to suppose a cube has the same surface area as the prism in problem 8. Find the edge length of the cube. So for me, the best thing to do is to start by drawing a cube. Now we're telling you that the surface area of this cube is going to be the same thing as that triangular prism. So the surface area is going to be 216 units squared. And we want to work backwards to figure out what is the length of an edge that will give us 216 units. Okay, so if you start thinking about surface area is the area of all of the sides added together. And a cube has how many sides? 6. Now what's special about a cube is the fact that all 6 sides are the same. And we're going to assume that all of these shapes I've just drawn here are all 6 squares, and they're all 6 squares the same size. Because when we find surface area, we are telling you that the area of this square plus 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 the area of this square and of this square is going to give us 216 units squared. So if all 6 areas have to be the same thing, since it's a cube which is made up of squares, I can take that 216 and divide it by 6. And when I divide 216 by 6, I'm going to come up with 36. So that means that the area of this is 36, and the area of this is 36. So the area of each one of these squares is 36, because when you add 36 6 times, you get 216. Now we want to know what's the length of the edge. So far we have found the area of the square. Edge is just talking about the side length of one of those squares. So if area is length times width, and in a square, that length and that width have to be the same thing, what can you multiply by itself to get 36? 6. So that means that the length of this square is 6, and the width of this square is 6, so its edge length is 6 units. As we continue to the next problem, it says to read the problem below, then use what you've learned about calculating surface areas of prisms to solve the problem. Mrs. Anderson wants to buy a glass greenhouse with the dimensions shown. The greenhouse will not have a floor. What is its surface area? So when we're looking at this shape, what 3-dimensional figure are we looking at? A pentagonal prism. Okay, so that's one of those composed figures where we have to break it apart. But there's something special about this problem. It does not have a floor. So the fact that it does not have a floor, that's going to adjust the way that we calculate our surface area. So again, we need to think about how many sides we have, how many areas we will find. So when we look at this and we kind of list out what we're looking at, we'll have 2 pentagons. And how many sides does a pentagon have? 5. So typically, if we're connecting 2 pentagons, then we would have 5 rectangles that connect them. But because we do not have a floor, we won't have 5 rectangles, we'll have 4. So when you look at the picture, it breaks down the problem to where you see the 2 pentagons and the 4 rectangles, because it's eliminating the bottom that it's sitting on because there's no floor. So you have your 2 pentagons with the appropriate measures and 4 rectangles. Now 2 of the rectangles are 15 by 8, and that is found here. You have 8 high here, so this is 8 as well, and 15 long. So those 2 rectangles are the 2 sides. When you look at the other 2 rectangles that are created that are 15 by 6.5, your 6.5 forms the roof, and on the other side would be the same, so that is 6.5 by 15. So those 2 rectangles come together to form the roof. After we pictured what shapes we're going to be looking at, you can model it, and you see that you're finding the area of one of the bases, which is a pentagon, by breaking it into a rectangle and a triangle, because we do know those area formulas. So that means that we can solve it with the area formulas for a rectangle, which is length times width, and the area formula for a triangle, which is 1/2 base times height, or we typically use base times height divided by 2. So now we're going to make some connections and go through and find the surface area of this greenhouse. Alright, now we're going to use the models and formulas to find the surface area of the greenhouse. We want to look at model it. How do you know that the height of the triangle is 2.5 feet? So we have this pentagon, and the pentagon that we were looking at had measurements of 6.5 feet, 8 feet, 12 feet, and an overall height of 10.5 feet. Once we've split that into a rectangle and a triangle, we tell you that the height is 2.5 feet. So we're wanting to know, where did that 2.5 come from? So if we want to know where the 2.5 came from, we'll take the height of the pentagon, which is 10.5, and we'll subtract it by the height of the rectangle, which was 8, and that gives us 10.5 minus 8 is 2.5. So that allows us to know the height of the triangle. For number 11, it says, what is the area of one of the bases of the prism? Show your work and explain your reasoning. The base of the prism is a pentagon, and we can break that down into a rectangle and a triangle, and we can find the individual areas. So the rectangle is 8 by 12, which means for the area you'll do 8 times 12, which is 96, and that is 96 feet squared. For the triangle, the measures that are important to get the area are the measures of the base, which is 12 feet, and the measure of the height, which is 2.5 feet. And we'll follow the area formula that it's base times height divided by 2. So that'll leave us with 12 times 2.5 divided by 2. 12 times 2.5 is 30. And 30 divided by 2 is 15. So if we want to get the entire area of the pentagon, we'll take our 96 feet and our 15 feet and add them together, which gives us 111 feet squared. So if we explain it, we're saying that you break down the shapes into a rectangle and a triangle, and you find the area of each and then combine them together. For number 12, it says to describe the other faces of the prism, including their dimensions. So the other faces are going to be 4 rectangles that are left. Two of them are 15 by 8. And 2 of them are 15 by 6.5. For number 13, it says, what is the surface area of the greenhouse? And show your work. This is where we have to account for both pentagons and all 4 rectangles. So we found that the area of one pentagon was 111 feet squared, and we have 2 of them. We said that we're going to have 2 rectangles that are 15 by 8. So 15 times 8 is 120. And since we have 2 of them, that gives us 240. We also had 2 rectangles that were 15 by 6.5. So that's 97.5. Since there are 2 of them, we'll multiply by 2 to get 195. And now that we've accounted for all of the faces, we'll add them together. So 111 plus 111 plus 240 plus 195 gives us 657. So that's 657 feet squared. So what we did was added both pentagons and all 4 rectangles. So in number 14, when it says explain how to find the surface area of any right prism, that's talking about regardless of the shape of its base. You find the area of each of the faces. And add them together. So now that we've practiced a pentagonal prism, finding its surface area, we want to try it. Use what you just learned about calculating surface area to solve the problem below. Show your work on a separate sheet of paper, but you're fine to work in your book. So you're going to find the surface area of the prism shown below. Include all faces, even the bottom. As we look at this problem, it might be helpful for us to look at the net of the figure, so that way we can see exactly how many areas we need to find. You can see that I've color-coded it by what sides have the same area. So you start in purple with the bottom, and the bottom is 30 by 120. So if you find its area, you would take 30 times 120. And that gives you 3,600. Next, you look at the green sections, and you can see that the green is 20 by 120. And 20 times 120 is 2,400. But this green section is the same as this green section. So we'll multiply that by 2. And that gives us 4,800. Now if you take a look at the blue sections, that is 120 by 17. Which is 2040. And again, this blue section is the same as this blue section, so we'll multiply that by 2 as well, giving us 4,080. And you can see what I've done there is I've taken the roof of the pentagonal prism and I have opened it up and laid it down. So I've accounted for the bottom, the two sides, and the roof. Now we're going to focus on the base. Now the base is a pentagon, but that pentagon can be broken down into a rectangle and a triangle. Your rectangle will be 30 by 20. Which is 600. And again, we have two of them because the bases are the exact same. So when we multiply that by 2, we'll have 1,200. And we also have two triangles, and the triangles are 30 by 8. So that is 30 times 8 divided by 2, since they are triangles. 30 times 8 gives us 240, and 240 divided by 2 is 120. So that means that the area of each triangle is 120, and again, we have two of them. So you'll multiply by 2. And that'll give us our 240. Now that we have found the area of all of the shapes, we'll add them together. So we'll add 3,600, 4,800, 4,080, 1,200, and 240. And when we do, that'll give us the surface area of this pentagonal prism. And that comes out to 13,920. We don't have a specific unit that we've measured in, so we'll call that 13,920 units squared, because this is area.